dy/dx लिखा है, तो वो तो पॉसिबल नहीं है ना। हेलो।
ओके, इसको आप, हाँ, ओके, ये टाइपिंग है, तो ये dx/dt करनी है आप।
जी सर, मैंने उस तरीके से करके किया, लेकिन मैंने भी असाइनमेंट के फर्स्ट जो लास्ट 2 क्वेश्चन है वो सेंड किए हैं। इसको मैंने dy/dx करके ना रेसिप्रोकल लेके भी सॉल्व करने की कोशिश की है, लेकिन वो जो है ट्रेजेक्टरीज बन रही है और वो बहुत डिफिकल्ट हो रहा है। तो अब आप अगर मैं ये इसको चेंज करके फिर आपको सेंड कर दे।
dx/dt कर लें।
फिर आप असाइनमेंट का टाइम एक्सटेंड कर दें।
ठीक है, आप जब भी जल्दी कंप्लीट करने आप जमा करा दें।
चले, थैंक यू सो मच सर। मैंने आपको ईमेल भी की थी सर, कि मैंने आपको ईमेल भी की थी, मुझे लगा शायद आपने देख लिया होगा, तो इस वजह से सेंड कर देंगे आज करके।
जो इसके जो राइट साइड पे जो है फंक्शन जो है वो वही रहेंगे, जो लेफ्ट साइड पे जो आप कह रहे हैं dy/dx, तो उसका dx/dt कर दें।
जी ठीक है सर, थैंक यू सर।
नेक्स्ट क्लास से पहले हम सबमिट करवा देंगे।
ओके। We will see next topic. This is a system of autonomous differential equation dx by dt is equal to f of xy and dy by dt is g of xy. This is where f and g are functions from r square to r are continuous. So functions f and g are defined over r square to r are continuous. We'll see some example of face plane portrait. This is some second order and non-linear differential equations. This is d2f by dt square is x minus x cube. Draw face plane portrait for this second order differential equation. So first, just express this second order differential equation as a system of two differential equations, and just substitute y is dx by dt to be some variable y. So this is dy by dt is x minus x cube and df by dt is just y. So you can see this is a system of two first order differential equations. Also this is a system autonomous differential equations. You can see this is independent of t, this is independent of t. So this is a system of two first order autonomous differential equations. Now from here you can see just dividing these equations, dy by dx is x minus y cube over y. If you just divide this equation by this, so you can see this x minus x cube over y. Now just separate variables, just shift these to left side, also shift these to right side. So this is y dy is x minus x cube dx. Now taking integral, so you can see this is just y square over 2 is x square over 2 minus x exponent 4 over 4 plus some arbitrary constant alpha. So just multiply this by 2. So you can see y square is alpha plus x square minus x exponent 4 by 2. So this is general solution of this differential equation. Now from here you can see y is plus minus alpha plus s square minus x exponent 4 by 2 square root. And also from here you can see this is defined for alpha greater than equal to minus 1 by 2. You can just find the domain of this function. for alpha equal to -1/2, x is just -1/1. For alpha greater than -1/2, less than 0, x belong to -1 plus 1 plus 2 alpha square root -1 minus 1 plus 2 alpha square root, or x belong to 1 minus 1 plus 2 alpha square root 1 plus 1 plus 2 alpha square root. And for alpha greater than equal to 0, x belong to -1 minus 1 plus 1 plus 2 alpha square root 1 plus 1 plus 2 alpha square root. So these are possible values for x according to alpha. So you can see face plane portrait of the given system. Differential equation is this. So you can see -1 for alpha equal to -1/2, x is just -1, or for alpha equal to -1/2, x is just 1. Also for alpha greater than -1/2 and less than 0, that this is the path, this is curve of this function y, and also this. And for alpha greater than for alpha equal to 0, this is the path of this function, and for alpha greater than 0, this is the path of this function. And also you can see from this differential equation dx by dt is y. So you can see for in upper half plane, y is greater than 0. In upper half plane, y is greater than 0, so dx by dt is greater than 0. So as t increases, x increases. So as t increases, x increases. So this is a direction of motion of the dynamics, and this is the direction of the path. तो जैसे t इंक्रीज करेगा, x इंक्रीज करेगा अपर हाफ प्लेन में. So these are the trajectories, and these are the curves of the solution. And portrait of the given differential equation.
अस्सलामुअलैकुम सर, मैंने अभी ज्वाइन किया तो सर अटेंडेंस होगी। और सेकंडली मैंने ये पूछना था कि जो मैंने असाइनमेंट आपको मेल किए मुझे एलएमएस का नहीं सब
अटेंडेंस होगी।
ठीक है सर। तो असाइनमेंट सर वो मैंने एलएमएस का नहीं अपलोड हो रही थी तो मैंने आपको मेल की थी अभी।
ठीक है
जी सर।
सर ने असाइनमेंट के लिए टाइम नहीं दिया, 1 वीक और।
अच्छा अच्छा
सर असाइनमेंट की लास्ट डेट क्या है सर?
क्लास तक क्या बताया तो ऐसा ने टाइम दिया है 1 वीक का।
कब तक का
जल्दी आप जल्दी जमा करा दें।
तो फिर बता दें।
Simple pendulum. So this is a pendulum of mass m, and this has length L, and this is just simple harmonic movement, and this is angle of rotation. So differential equation of this simple pendulum is m d2 theta by dt square is minus mg sine theta. You can find this differential equation. G is acceleration due to gravity. Just divide this equation by ml, so you can see this is d2 theta by dt squared plus g over L sine theta is 0. This is a second order linear differential equation. Now just introduce another variable, just transform t to s, and so this is just substitute t is L over g square root s. So you can see then theta of L over g s square root is just denote this by x of s. So this differential equation reduces to this d2x over ds square plus sine x is 0. So this differential equation is called pendulum equation. Now just introduce dx over ds is y, dx over ds is just y. So d2x over ds square is dy by ds. So this is dy by ds is minus sine x, dx over ds is y. So you can see this is a system of autonomous differential equations. Now just divide these equations. So dy by dx is minus sine x over y.
ये ठीक है, वैल्यू नहीं समझ आई कैसे निकाली है।
t को सब्स्टिट्यूट किए ये L over g s के रूट।
ये ऐसा खुद से किया सब्स्टिट्यूट के वैल्यू निकाली हुई है किसी
This is change of variables.
अच्छा मतलब सिर्फ ठीक हो।
Now dy by dx is minus sine x over y. Now just shift y to left side, also shift dx to right side, so you can see this is y square is 2 cosine x plus alpha. These are solution curves, and this is general solution of this differential equation. And from phase plane portrait for the pendulum equation for various values of parameter alpha are given in this diagram. And for alpha equal to the curve is y square is 2 cosine x plus 2. This is this curve is called the equation of separatrix. And as about direction of motion of these curves, so you can see df by dt is y. So df by dt is y is positive in upper half plane. So as here you can see this is df by ds is y. So as so in upper half plane y is positive, so df by ds is positive. So as x increases, x increases. So this is direction of motion of this curve. So this is direction of motion. This is direction of motion of these curves.
ये आवाज आ रही है आप लोगों को?
ये जो ऑनलाइन क्लास होती है ना, इसका एक मसला ये भी है कि ना जो पढ़ाने वाला ना वो फुल टाइम बोल नहीं सकता। मतलब आप अगर समझे कि कंटिन्यूसली एक बंदा बोलता चला जाए तो ऐसा नहीं हो सकता।
इसमें ये भी नहीं ना पता चलता कि हमारा नेट चला गया कि अगले बंदे का मसला हो गया। तो
कोई बात नहीं, अगर नेट चला भी जाए थोड़ी देर के लिए या आ भी जाए तो
इसलिए ना कंफ्यूज हो जाते हैं कि शायद हमारा प्रॉब्लम है या आगे से प्रॉब्लम है।
ठीक है। तो
सर दो तीन दिन से लाहौर में तो नेट का भी बहुत ज्यादा इशू आ रहा है।
सही। तो क्योंकि आपको मैं बताऊं जो क्लास होती है ना, यानी फिजिकल क्लास तो क्लासरूम में उसमें इतना नहीं बोलना पड़ता जितना ना ऑनलाइन में। तो ऑनलाइन में बहुत बोलना पड़ता है और वो मुश्किल होता है। थोड़ी देर बाद
ये होता है ना, फिर सबको इश्यूज आ रहे होते हैं, हर कोई अपना अपना इशू लेके बैठा होता है, तो डिस्टर्बेंस बहुत ज्यादा होती है।
नहीं, मैं वैसे मतलब पढ़ाने की तरह से बात कर रहा हूँ। बोलना ना यानी एक हद तक तो पॉसिबल है बोलना, उससे ज्यादा नहीं बोला जा सकता। यानी जैसे फिजिकल क्लास में समझे कि अगर 15 मिनट्स पढ़ाया तो 5 मिनट की ब्रेक भी बंदा ले लेता है। जैसे स्टूडेंट को कोई कह दिया कि ये क्वेश्चन आप लोग करेंगे इस तरह से। तो जो ऑनलाइन जो है ना वो जाहिर इतना टाइम जो है ना मतलब बोलना मुश्किल है थोड़ा।
सर आप हमें बता दिया करें ना, फिर हम कंफ्यूज हो जाते कि नेट तो नहीं चला गया।
ठीक है।
ये सर प्रेशर हो सके।
जी सर, आप ब्रेक लेना चाहें तो कोई मसला नहीं सर, बस बता दिया करें, बाकी कोई इशू नहीं है सर।
क्योंकि वैसे हम पूछते हैं ना, बार बार डिस्टर्बेंस होती है, बाकी क्लास डिस्टर्ब होती है।
ठीक है, सही।
जैसे मतलब थक जाता है।
Well, see, another definition, this is a system of differential equations. df by dt is partial h over partial y, and dy by dt is minus partial h over partial x. And this, where h is a function from r square to r, is continuous, and its first order partial derivatives are also continuous. ये जो h जो गिवन फंक्शन जो है ये नॉन फंक्शन है, ये r स्क्वायर टू r जो है ये कंटिन्यूस है और इसके फर्स्ट ऑर्डर पार्शियल डेरिवेटिव जो हैं वो भी कंटिन्यूस हैं। देन दिस सिस्टम ऑफ डिफरेंशियल इज कॉल्ड Hamiltonian system. For example, you can see this is a Hamiltonian system. This is df by dt is y, dy by dt is minus sin x. So you can see here partial h over partial y is just y.
सर एक दफा ये डेफिनेशन दोबारा रिपीट कीजिएगा.
ये एक डिफरेंशियल इक्वेशन है df by dt is
जी
पार्शियल h ओवर पार्शियल y. इसी फंक्शन का जो पार्शियल डेरिवेटिव विद रिस्पेक्ट टू y है वो df by dt के इक्वल है. और किसी फंक्शन का जो पार्शियल डेरिवेटिव विद रिस्पेक्ट टू s जो है उसका माइनस टाइम और dy by dt के इक्वल है. अब नाउ h is सम गिवन फंक्शन होगा h जो कि r स्क्वायर से r तक कंटिन्यूस है और इसके फर्स्ट ऑर्डर पार्शियल डेरिवेटिव्स हैं वो भी कंटिन्यूस हैं. तो इस तरह का जो सिस्टम ऑफ डिफरेंशियल इक्वेशन जो होगा उसको ऑटोनोमस डिफरेंशियल इक्वेशन उसको हैमिल्टोनियन सिस्टम कहते हैं.
ठीक है.
So you can see this is an example of a Hamiltonian system. df by dt is y and dy by dt is minus sin x. You can see partial h over partial y is just y minus partial h over partial x is minus sin x. So from these equations you can find h is y square by 2 minus cosine x. So this function is called Hamiltonian function. Further dh by dt is just use differentiation rule, chain rule, partial h over partial x, df by dt plus partial h over partial y dy by dt. So this is partial h over partial x and dx by dt is just partial h over partial y partial h over partial y dy by dt is minus partial h over partial x. So you can see these are cancelled with each other, so this is just 0. So you can see dh by dt is 0. So derivative of Hamiltonian function is 0. So Hamiltonian function is a constant. Hence orbits are the function h of fy is c, because you can see from this differential equation h is just equal to some constant c. Hamiltonian function is usually represent the total energy of a dynamical system. Usually this is Lagrangian path.
क्या हाल चाल है? शुक्र अल्लाह का.
Let's see another example. This is this is the system of first order differential equations. This is df by dt is. This is a system of first order differential equations. df by dt is 3y square minus 2x2y Also dy by dt is 3x square y square minus 2x. Find all the Hamiltonians for this system of differential equations. So you can see dx by dt is partial h over partial y. So just consider this partial h over partial y is 3y square minus 2x cube y. Now integrate this partially with respect to y. So you can see h is integral of this is y cube by 3. So this is just y cube minus integral of this is x cube y square by 2. So this is minus x cube y square plus some k depending on x, because this is just partial integration. Now just differentiate this partially with respect to x. So partial h over partial x is partial by partial x of derivative, this is just 0, derivative this is minus 3x square y square plus this is just depending only on x, so this is dk by dx. Now partial h over partial x is minus g of xy, so this is 2x minus 3x square y square. Now using this over here, so you can see minus 3x square y square plus dk by dx is 2x minus 3x square y square. Now this is cancelled with this, so dk by dx is 2x. So k is x square.
क्या हाल है बेटा? शुक्र अल्लाह का, ठीक ठाक जिंदा अभी सारी पूरी है।
फैसल भाई अपना माइक ऑफ करें।
So this is cancelled with this. Now dk by dx is just 2x, so k is x square plus some arbitrary constant alpha. So h of xy is y cube minus x cube y square plus x square plus alpha. So these are Hamiltonians for the given system of differential equations. We'll see next topic. This is phase plane portraits for linear system of autonomous differential equations. So this is a linear system of first order differential equations. This is dx by dt is a11x plus a12y, and dy by dt is a21x plus a22y. And so you can see this is a first order linear differential equations. Also this is a first order linear differential equation. Here x is independent variable, t is independent variable, y is dependent variable, t is independent variable. A11, A12, A21, A22, these are constants. Also, this matrix of coefficients is invertible. That is, df by dt is non-zero. This is invertible. For equilibrium points of this system of differential equations, just consider a11x plus a12y is 0. Also a21x plus a22y is 0. And now solving this, so you can see this can be expressed as this: a11, a12, a21, a22, xy is 0, 0. So this can be expressed as A. This is matrix A. Xy is 0, 0. Now just taking A inverse, so you can see because A is invertible. So xy is 0, 0. So xy is 0, 0. So 0, 0 is the only equilibrium point of system of linear differential equations. Also for lambda is equal to 0, a minus lambda ix is 0. So this implies lambda is 0, so this is just ax is equal to 0. So this implies x is 0. From it just taking a inverse, so you can see x is 0. So this implies that lambda is equal to 0 is not an eigenvalue for the matrix A. तो ये जो मैट्रिक्स ए जो है लैम्डा इक्वल टू 0 इसकी आइगन वैल्यू नहीं है. The first imported depends on the eigenvalues lambda 1 and lambda 2 of the matrix A. Therefore, we consider various possible cases for eigenvalues lambda 1 and lambda 2 of the matrix A. तो जो इसका first imported जो है वो आइगन values lambda 1 lambda 2 पे डिपेंड करता है. So consider various possible cases for eigenvalues lambda 1 and lambda 2. Well, consider the first case. This is eigenvalues lambda 1 and lambda 2 are distinct and positive. That is, lambda 1 is greater than lambda 2 is greater than 0. Draw first name portrait for the system of differential equations. This is ds by dt is 3 by 2x plus 1 by 2y. Also dy by dt is 1 by 2x plus 3 by 2y. The characteristic equation for this system of differential equations is a minus lambda I determinant is 0. So this is 3 by 2 minus lambda 1 by 2, 1 by 2, 3 by 2 minus lambda determinant is 0. Now expanding this determinant, so you can see this is lambda square minus 3 lambda plus 2 is 0. So lambda has values 3 plus minus 9 minus 8 square root over 2. So 2, 1, these are eigenvalues of matrix A. So you can see lambda 1 is equal to 2, lambda 2 is equal to 1. These are two eigenvalues. So lambda 1 is greater than lambda 2 is greater than 0. Now find eigenvectors corresponding to these eigenvalues. So 1, 1 is a eigenvector for eigenvalue lambda 1 is equal to 2. Also 1 minus 1 is an eigenvector for eigenvalue lambda 2 is equal to 1. So general solution of a system of linear differential equations is so general solution for this system of differential equations is x y is c1 exponential of 2t 1 1 plus c2 exponential of t 1 minus 1, where t belongs to R. This is domain of domain of this solution. This is general solution. For C2 is equal to 0, you can see this is x of t is C1 exponential 2t, y of t is C1 exponential 2t. Both are equal. You can see if C2 is 0 and C1 is greater than 0, then x is C1 exponential 2t. Also y is C1 exponential 2t. So both are equal. So this is a graph of this solution. This is a parametric plot. This is x, this is y, and this is as t increases, and these values increases. So this is direction of motion of this solution. Also for C1 greater than 0 and C2 is equal to 0. Also for C1 less than 0 and C2 greater than 0, you can see x is C1 exponential 2t, y is C1 exponential 2t, and these both are equal. And as t increases, x decreases and y decreases. So you can see this is direction of motion of this solution. Also, if C1 is 0 and C2 is greater than 0, then graph of solution is for C1 equal to 0, C2 greater than 0. This is solution curve. This is parametric curve of solution x and y. For C1 equal to 0, C2 less than 0, this is solution. You can see And this is solution for C1 equal to 0. So f of t is C2 exponential t, y of t is C2 exponential minus C2 exponential t. So you can see both are equal but of opposite sign. So f of t is C1 exponential t, y of t is minus C2 exponential of t. So for C2 less than 0, and the graph of this solution is this one. And for arbitrary values of C1 and C2, you can see for C1 other than 0, C2 other than 0, and just consider general solution. Fy is C1 exponential 2t, 1, 1 plus C2 exponential t, 1 minus 1. Now just taking exponential t common, so this is exponential t into C1 exponential t 1, 1 plus C2 1 minus 1. For small value of t, that is as t approaches to minus infinity, then this is just 0. So this is exponential t is C2 1 minus 1. So as t approaches to minus infinity, the solution approaches to the origin in the direction of the vector 1 minus 1 for C2 greater than 0, and in the direction of vector minus 1, 1 for C2 less than 0. Also, general solution Fy is C1 exponential 2t, 1, 1 plus C2 exponential t, 1 minus 1. Just taking exponential 2t common, so this is C1 1, 1 plus C2 exponential minus t, 1 minus 1. And as t approaches to infinity, this is 0, so this is C1 exponential 2t, 1, 1. So for lambda 1 greater than 0, lambda 2 greater than 0, origin is unstable equilibrium point. And you can see phase plane portrait of this system of differential equations. These are the solution curves for various values of arbitrary constants C1, C2, and you can see this is moving away from the origin. This is also moving away from the origin. These are moving away from the origin. So origin is unstable equilibrium point. now attendance